Hi guys, my name is Woon. So welcome to our Headwave presentations, and our project title will be Smart Cage Free Chicken Coop project. So here are some of my team structures with team leader Cho Jin-Yuen and assistant leader, which is me, Woon Shun-Yuen. And we have other 3 members here, total of 5 members. Now I'll talk a little bit about an introduction of our project. So we are aiming to do an AI farm which consists of environmental monitoring and control system. Secondly, this system will be run by fully DC power-up systems. Then C, we have acoustic monitoring for all the chicken sounds and everything. And D, we have a remote control door which can allow the chickens to be caged inside an area. And we have E, an AI-powered chicken detections for counting of chickens using the camera. And we have F, of course, cloud computing, which collects all the data. Now, problem statement here by facing by the farmers, which is first one, lack of automated monitoring. In this case, when it's lack of automated monitoring, it will lead to a poor air quality, of course, a temperature imbalance, and some inefficient management. Secondly, a labor-intensive operation is there, mainly because of the poultry farming increase the workload. Alright, and then of course when there's the increase of the workload, there's a reduce of the productivity of the farm. And lastly, a resource inefficiencies is there because of the wastage and increase of operational costs. Okay, which will impact the sustainability and profitability of the farm. Now, I'll move on to a design process. The first one is me. I'll be doing 2 things in this project. First one is sensors integration and designing the DC power system for powering up the whole sensors. I'll be using 5 different kind of sensors and with a DC fan for ventilation. Now, first one, DHT11, temperature and humidity. Secondly, PR motion sensors to detect motion. Thirdly, LDR sensors to detect light intensity. And fourthly, an MQ135 gas sensors to detect any hazardous gas in the area. And then we have also a weight loop sensor, which is called HX711. So a DC fan is there to do a simple ventilation system when there's a hazardous gas detected.Moving on to power system, I mainly uses an LM2596, which is a DC-DC converter to convert a 12-volt DC battery to a 5-volt DC battery for all the microprocessors and sensors. And then a Q switch is there to turn off the system. jack is there, the battery from the DC-DC converter. And then there's also, of course, a 12-volt DC still as a battery and some ribbons cable for connections.
Hi everyone, my name is Cho Jin-Yuen. My task is to perform acoustic monitoring on classifying different chicken sounds. There are 3 main steps to perform this task, and the first one is transform the audio files into spectrograms. After that, I use the spectrograms to train the dataset using the TensorFlow technology. The last one is the real-time sound classification. This is the first step, transform the audio files to spectrograms. And this is the one of the example of the spectrograms. You can see this is the chick chirping spectrogram with the frequency around 4000 Hz. The x-axis is the time domain and the y-axis is the frequency domain. After that, I use all the datasets to train my model. This is the file directory, and the first one is the train, and the second is the validation. There are 5 categories. As you can see, the first one is chick, roaster, farm noise, speech, and silence. This is the final step, which is real-time sound classification. This is the GUI. As you can see, the result is detected like silence, chick chirping, chicken farm noise, rooster crowing with the confidence level. As you can see, the last one is the speech with the confidence level. After the user press the exit program button, there's a dialog will display. After the user press the exit program button, then the program will be terminated. And this is the output, which is also shown in terminal.
Hi, my name is Samuel Benjamin Marengo, and for my part, I developed a remote control door that can be operated using Wi-Fi and the blinker. Here's a sample code that developed in the Arduino IDE, where you have two set of code, one for toggling the safety switch of the door, and another one for toggling the actual door. Here is the sample parameter that I have inputted inside the Blink app. So you have to make it correlate with the Arduino IDE code that you developed.
Hi, my name is Junkan, and what I'm doing is the AI powered chicken detection using the YOLO V8 and the OpenCV. The YOLO V8 is for the object detection, and we have created the API, which is can select the video source from the cameras or the files. Annotate the videos and detect the result. Key features of this thing is the camera detections, which can scan on and list the connected cameras automatically. You can see it here. Here is the quick scanner result for the cameras. And next we have the file sections, which allow the user to go to files, which MP4 and SD. And here is the file section. And next, for the real-time processing, we can annotate the videos with the frame per second and number of chicken. And here is the UI, which is user-friendly. Next, here is the chicken detection result. You can see the background image. We have the 4 chicken being detected, as shown here. And the frame per second of the result is 31.2. Next. This is the final prototype we have done. And this is the door. And you can see this backside have the skill. And here is the speed cameras for image processing and ventilation fans. That's all for the prototype.
So for the results, I will explaining some of my parts in here. So mainly I've developed a live database by using a Google Firebase to collect all the data from what my microprocessor ESP8266 has collected. So in here, as you can see, there's the date and then some of my sensors here. So you'll be showing some values here. So therefore, we will be using all this data to integrate into a web dashboard for users to easily monitor. So for that part, I'll pass it to my teammate, Gregory. Thank you.
I'm Gregory. Now we're talking about the web dashboard. So for the integration of the web dashboard, I integrated with Woon so that all the environmental data can be shown on the web dashboard for users to view. So here we have the simple login page, and this login uses authentication from Google Firebase, which Woon has talked about. And here, for the integration of the AI chicken count as well as the sound detection, we have showing the active number of chickens that are counted in the farm and the active sound that is being recorded, as well as the confidence. So this is the main web dashboard, and from this web dashboard, users can select a date range to view the data that has been collected. And here, from the data that has been collected, the temperature, humidity, and air quality, which would be the ammonia levels, are shown. So very easy to understand. The green colors and the text saying good, optimal, or if it is in bad condition, then poor. As well as analysis is done on past data that has been collected, and the trends for the past data will be shown as rising or falling. So next slide, please. All the data will be shown in a chart format so that it is easier to understand and analysis can be done. So for this chart, the user has selected already which date range that they wish to view, and all the dates with all the times are shown with all the different values that have been collected for this past few days. That is it for the web dashboard, and now we'll show the demonstration video.
Hi guys, so I'll be showing you the final prototype made of a wooden frame and some sensors. So here please. So this is the microprocessor of ESP8266, and then here is the microprocessor of ESP32, and then some of the sensors they have attached here. So first one is the DHT11 temperature sensors, and in here we have MQ135 gas sensors, and here we have an LDR sensors, okay, and also below we have an motion detector sensors. And here is a little DC 12-foot fan for demonstration purposes of the ventilations. And here is my DC converter. All right, and then some of the kill switch, and finally we have a dash cam for the chicken counting by using the YOLO by one of our teammates for monitoring purposes lah. Okay, and lastly, here is the weight sensor of HX711, and also the automated door is right in front of the gate, okay, of the frame. So actually the frame is actually represents the farm area. So this is a structures to show on the systems inside a farm. So now I will pass it to my teammate Samuel to explain his door.
Hi, my name is Samuel. To start, I will start by showing the remote control, where you have one toggle button for the safety lock and one toggle button for the actual door. So I will show a little demo where you can toggle to open the safety lock, and then you can toggle to open the door. I will now show another small demo of closing the door and closing the safety lock.
Hi everyone, my name is Chu Jingyuan. My task is acoustic monitoring on classifying different chicken sounds. The aim of this task is to enhance understanding of poultry behavior and farm conditions, enabling efficient monitoring and providing valuable data for farm management. Without wasting the time, I'm going to start my program. When I'm not talking, so silence will be detected. When I'm talking now, so you can see the speech is detected. Now I'm going to play some chicken sounds. Chick chirping sound. Chicken farm noise. Rooster crowing. When I press the exit program button and I press OK, the whole program will be terminated. You can see this is the terminal of my program. All the output is also shown here, and the program exited successfully after I press the exit program button. That's all. Thank you.
Hi everyone, my name is Jun Kang. Let me introduce you to the chicken detection system for the chicken cage. Here are the code for the chicken detection, and the script integrate the object detection with the YOLO V8. You can see here. Allow the user to either select the cameras or using the processing video, which we can input the video inside so that it can process it, and it can detect the chicken's object which is classified as the birds. You can see here, and it can detect without doubt. Let me start run the GUI. We can see here is the camera. We can select the camera for the detect for the chicken. You can see here, it shows that the cameras we can select, and if we have more than one cameras, we can select more cameras at here. I will show for the video processing. So you can see, can select the video. You can see it can detect the birds, which is the chicken, detect and classifies birds, and you can see that the frame per second of the processing the image is very slow because of the processing image, and you can see this total out of 2 birds and which is counting the numbers of the chickens. And that's all for the videos. Thank you.
Lastly, this is the conclusion of this project. First, we improve the poultry management by enhances the poultry farming efficiency. The second is technological integration. We integrate IoT, AI, and real-time data analysis in our project. The third one is the sustainability and productivity. The system reduces the resource wastage, minimizes labor dependency, and promote ethical animal care. The last one is the scalability and adaptability. Our design is adaptable for diverse farming needs, from the small scale to the large scale. That's all our presentation. Thank you.